As a little Hawaiian, my mom and auntie always told me stories about Kalaupapa, the Hawaiian leper colony surrounded by the highest sea cliffs in the world, and Father Damien, the Belgian missionary who gave his life for the Hawaiian community. As a young nurse, my aunt trained the nuns caring for the remaining lepers almost 100 years after Father Damien died of leprosy. I remember stories she told about traveling down switchback cliff paths on a mule while my uncle played her favorite hula songs on the ukulele all the way down to Kalaupapa. You see, as a youngster, I was always curious about a few things. First was why a Belgian missionary chose to live in complete isolation in Kalaupapa, knowing he would inevitably contract leprosy from the community of people he sought to help. And secondly, where did the leprosy bacteria come from, and why were Kanaka Maoli, the indigenous people of Hawaii, so susceptible to developing leprosy, or mai pake? This got me curious about what makes us unique as Hawaiians, namely our genetic makeup. But it wasn't until high school through the Human Genome Project that I realized I wasn't alone in trying to connect our unique genetic ancestry to our potential health, wellness, and illness. You see, the $2.7 billion project promised an era of predictive and preventative medicine based on our unique genetic makeup. So to me, it always seemed obvious that in order to achieve this dream, we would need to sequence a diverse cohort of people to obtain the full spectrum of human genetic variation on the planet. That's why, 10 years later, it continues to shock me knowing that 96% of genome studies associating common genetic variation with specific diseases have focused exclusively on individuals of European ancestry. Now, you don't need a PhD to see that that leaves 4% for the rest of diversity. And in my own searching, I've discovered that far less than 1% have actually focused on indigenous communities like myself. So that begs the question, who is the Human Genome Project actually for? Just like we have different colored eyes and hair, we metabolize drugs differently based on the variation in our genomes. So how many of you would be shocked to learn that 95% of clinical trials have also exclusively featured individuals of European ancestry? This bias and systematic lack of engagement of indigenous people in both clinical trials and genome studies is partially the result of a history of distrust. For example, in 1989, researchers from Arizona State University obtained blood samples from Arizona's Havasupai tribe, promising to alleviate the burden of type 2 diabetes that was plaguing their community, only to turn around and use those exact same samples without the Havasupai's consent to study rates of schizophrenia, inbreeding, and challenge the Havasupai's origin story. When the Havasupai found out, they sued successfully for $700,000, and they banned ASU from conducting research on their reservation. This culminated in a sort of domino effect with local tribes in the Southwest, including the Navajo Nation, one of the largest tribes in the country, putting a moratorium on genetic research. Now, despite this history of distrust, I still believe that indigenous people can benefit from genetic research. And if we don't do something soon, the gap in health disparities is going to continue to widen. Hawaii, for example, has the longest life expectancy on average of any state in the US. Yet Native Hawaiians, like myself, die a full decade before our non-Native counterparts because we have some of the highest rates of type 2 diabetes, obesity, and the number 1 and number 2 killers in the US, cardiovascular disease and cancer. So how do we ensure that the populations of people that need genome sequencing the most are not the last to benefit? My vision is to make genetic research more native, to indigenize genome sequencing technology. Traditionally, genomes are sequenced in laboratories. Here's an image of your classic genome sequencer. It's huge. It's the size of a refrigerator. There's this obvious physical limitation. But what if you could sequence genomes on the fly? What if you could fit a genome sequencer in your pocket? This nanopore-based sequencer is 1/10,000th the size of your traditional genome sequencer. It doesn't have the same physical limitations in that it's not tethered to a lab bench with extraneous cords, large vats of chemicals, or computer monitors. It allows us to de-black box genome sequencing technology development in a way that's immersive and collaborative, activating and empowering indigenous communities as citizen scientists. 100 years later in Kalaupapa, we now have the technology to sequence leprosy bacteria in real time using mobile genome sequencers, remote access to the internet, and cloud computation. But only if that's what Hawaiian people want. In our space, on our terms. Indigenomics is about science for the people, by the people. We'll be starting with a tribal consultation resource focused on educating indigenous communities on the potential use and misuse of genetic information. Eventually, we'd like to have our own Indigenomics Research Institute to conduct our own experiments and educate the next generation of indigenous scientists. In the end, indigenous people need to be partners in and not subjects of genetic research. And for those on the outside, just as Father Damien did, the research community needs to immerse itself in indigenous culture or die trying. Mahalo.